This video is going to be a challenging one. It's going to be a long one. And if you came looking for how to solve compound inequalities, you came to the right place. Compound inequalities, I'm going to introduce you to them. And I'm going to take you through some problem solving with them. So first of all, what is a compound inequality? Well, compound inequality, the word compound means basically to combined elements. Combined. Let's just say combined for this time. So a compound inequality is when you know what an inequality is. It's 2 is less than 6 or x is less than 6. You know that. So a compound inequality, what it does is it combines multiple inequalities. Let's erase this one and let's say we have over here x is, let's say it's greater than 2. Okay, x is greater than 2 and x is less than 6. So what happens is we combine them to get 2 is less than x and x is less than 6. And this is a compound inequality. Okay? So that's what a compound inequality is. It combines inequalities. So it combines them in two inequalities into one statement. And now we ask, what about it? Well, there's why is this useful? Why is this a useful tool? Well, there's two types. There's and inequalities or compound inequalities and or. And inequalities and or. So let's just dive a little deeper into what those are. So when we see something like, let's stick with the example, when we see something like x is greater than 2 and x is less than 6. What does that mean? That means both are true. So in this situation, both must be true. X must satisfy both requirements. Both must be true. Or x satisfies both. X satisfies both. And furthermore, and is between two values. Between. Let's put between up there. Erase that portion, bring the weight down a little bit. Between. And is between. Okay. So now that I wrote that, it's going to be a very visual thing. But before I graph it, let's go over to or. What about when we have an or statement? So when we have an or statement, this is going to be written as, we're going to take the statement x is less than 2, or, and this is how you'll see it mathematically, or x is greater than 6. So now what or is given us is outside. We'll say outside a range. Outside a range. So we're given a range, and or can satisfy either of them. So either is true. Either is true. Or in other words, x satisfies either. Satisfies either. Satisfies either. Now, we've talked about it and you've seen some of it, but now let's graph it so you can really see what I'm talking about here and see why this is useful. So if first of all, let's rewrite the and statement. This is the way you're going to see it expressed mathematically. X is going to be in the middle, X is going to be greater than 2 and less than 6. Okay? Let's write that up here. So X is in the middle, it's greater than 2, and it's less than 6. Remember, this is a range. So we're going to put a open circle at 2, and we're going to put an open circle at 6. And X must be a number between these 2 points. That is what this statement here is saying. X must be a value between those points. Any value not in that point will not satisfy the inequality. So now this, what you see here, is how you will see it expressed mathematically. Okay? So let's consider that. What is, so X can be either less than 2. Okay, so we're going to have a point we're going to put it on the bottom here. We're going to have a point at 2. It can be less than 2, or X can be greater than 6. You're going to have a point at 6. Now, what's different? What is this statement really saying? X can be less than 2 or greater than 6? What is that really saying? Think about that. Well, it's saying that any value laying outside of that middle point, outside of the numbers between 2 and 6, can satisfy the equation or the inequality. I should say the inequality. So basically, when you look at an and statement and a or statement, they're more or less, or they are opposites. They're saying the opposite thing. And is saying the values between, or is saying the values outside of. Okay, now there's other variations where these move around and such, which we will certainly do in due time. So let's clear this out. I hope all of that makes sense. And we're gonna start working on some examples and graphing them out. So now we're gonna work on an example. Let's make this, let's say, example 1. And we're going to do 1 is less than X and plus 2, which is in turn less than or equal to 5. Okay? So let's clean that up a little bit. So we're given this compound inequality. 1 is less than X plus 2, which in turn is less than 5. So first of all, think about this. What kind of statement is this? Is this an and, or is this, it's either an and statement or a or statement? Which do you think it is? It's an and statement. And statement. So how do we approach this? Well, we solve and then we graph. And you can imagine this, anything you do to one side, anything you do to one of these, you must do to all of them. If you subtracted 2 from the statement in the middle, if you subtract 2 from here, you must subtract 2 from the 1 and subtract a 2 from here. And this will remain true. And you could do anything. You could add 3 to this. So long as you add 3 to this and this, it will remain true. So that's how we're going to solve this. We're going to subtract 2 from all sides. we're going to get -1 is less than x, which is less than or equal to 3. Okay, so this is how I'm going to approach graphing this. We're going to have an open circle at the point -1. -1. Now, x, if we look here, x is less than 3, so we're going to have another point at 3. This time it's less than or equal to, so it's going to be a shaded point. And now all we have to do is connect the two. So every value greater than -1 and equal to 3. So 3 will satisfy it. Let's throw up some random points. 2.99 will satisfy it. 1 will satisfy this inequality. -0.5 will satisfy it. And 0.99, -0.99 will satisfy it. But -1 will not, because it must be greater than -1. Okay. So we just solved an AND statement. And we're seeing that this is a range. This is giving us a range, an in-between of two, any number between 2 points. So now let's dive into an OR. Let's get into more of an OR statement. Let's consider, let's do x minus 3 is less than 1, or x minus 3 is greater than 5. So remember, this means if x satisfies either value, it's true. So let's go ahead and solve this. So now we have two separate statements. Okay, these are two separate statements, so don't get confused with the previous rule I told you. If you subtracted 2, you must do it to every side. Well, now you have two separate statements. OR statement is two separate statements. So it's valid. We'll plus 3 to both sides, and we'll get x is less than 4. And then we'll add 3 to both sides over here, and we'll get x is greater than 8. So now we've set up 2. We'll just say that it's still OR, okay? And now our next step, we're given 2 inequalities, and we're going to graph them on the number line as a compound inequality. Okay, so x is less than 4. So we're going to have an open circle at 4, or x is greater than 8. So we're going to have an open circle at 8. Okay, so you see that x must be less than 4, so everything in this direction satisfies the compound inequality, and everything in this direction satisfies the compound inequality. But anything within this point will not satisfy the compound inequality. Okay, let's move on to some practice problems. Here's a practice set for you to develop your skills on. You can solve them, and then I'll solve them myself. I'm sure you did very well with that, and I'm going to work through it, and I'll solve and graph. I'll work more quickly this time. So whatever you do, so we have an AND statement for the first one. So we're going to subtract 1 to isolate the variable, and we'll find that 1 is less than x, which is less than 6, less than or equal to 6. All right, so now we've solved that and equality. We just have to graph it. So we'll have an open circle at 6. And then we'll have a shaded circle at 6 because it's less than or equal to. We'll have an open circle at 1. And now with an and statement, every value between 1 and 6, including 6 but not including 1, will satisfy the inequality. Let's move on to the orange problem here. Okay, we have -6 is less than or equal to 3x, which is less than 9. So we need to isolate the variable, solve first, and then graph, as we have learned. So we're going to divide each of these by 3. So now we have -2 is less than or equal to x, which is less than 9. Not 9, we divide it by 3, which is less than 3. Right, so we will have an open circle at the point 3, and we will have a closed circle at the point -2. Okay, and then this is an and statement, so we connect those two, and that's how we solve and graph that problem. Finally, we're working on an or statement. Over here, top right in the blue, we have -2x is greater than or equal to 6, or -2x is less than or equal to -4. So now we solve these independently. So we divide both sides by -2, and now you must use the very special rule we recently learned and flip the inequality sign. Now we find x is less than or equal to -3, right? Or now we solve the other side of the equation. We have -2x is less than or equal to -4. So we are going to divide both sides by -2. And we must again use our special rule where we flip the inequality sign, and we find that x is greater than or equal to 2. Let's graph that. So x must be less than or equal to -3. So we're going to have a shaded circle at the point -3. Now x must be greater than or equal to 2. So we're going to have another shaded circle at the point 2. Now with an or statement, what we do is we don't connect the dots, rather we stretch away, because every value greater than 2 satisfies this compound inequality, and every value less than -3 satisfies this compound inequality. So I know that was a lot, but that's it for this session. If you got something of value out of this, subscribe or leave a comment.